Hello and welcome back. In this lecture I want to talk about format specifiers. So this is in the section for variables and data types, and the reason is it's very important to be able to display the value of variables as output, and format specifiers basically help you do that. So I want to run through some examples of showing how you can display the value of variables, and we're going to use format specifiers to specify the type of data that we want to display. So format specifiers are used when displaying variables as output. You can also use them for converting data, but we're just going to talk about using that as output for now. They specify the type of the data of the variable that you want to display. So for example, if you declare an integer named sum and it's equal to 89 and you want to display that variable sum, what you would do is you would use the printf function, and it looks kind of weird, right? The thing that you should really notice in this printf is there's a percent symbol there. And the way that you know, the way that you're going to be able to identify a format specifier is through that percent symbol. So format specifiers are exactly what the name implies, in that they specify the format of data and how the format should be, basically how something should be formatted or displayed. So in this example, printf is a function that we've been using to display output. We know how to do this because we had a couple, many different examples and a challenge. Printf is a function, right? A function, again, we haven't talked about functions in detail, but a general concept of a function just means that it's a group of code. It's a way of organizing things, like an algorithm could be inside of a function. Function has specific syntax in C in that you see parentheses with it. So we know the main function is the way that you enter a program. So we're familiar with at least one function called the main. We've also been learning about printf because that's one of the functions that you use to display output to the console. So it's important to understand those two basic functions. We don't have to understand everything about functions up to this point. We just need to know that a function can be invoked or called to do something. And in this case, we're using the printf function to display output. And we're telling it what to display based on what's inside these parentheses. Right? So printf is a function. It can display the output of variables. Up to this point, if we wanted to display something using printf, we just enclosed it in double quotes and we saw text go out to the screen. But what happens when you want to print out a variable? Well, when you want to print out a variable, you have to specify the type of the data for that variable that you want to print. The printf function needs that information. So if you look at printf and you're trying to analyze it, you don't know anything about functions yet. Things that should stick out to you are that, hey, it has a left parentheses and a right parentheses. There's a comma in there. There's quotations in there. And the comma, first of all, you're going to know it's a function because of the parentheses. And inside those parentheses are what's called function arguments. It's data that you're passing to the function that can be used. And again, it's not real important that you understand all of this, but it is arguments, and the arguments are separated by comma. So the first argument for the printf function is everything inside those double quotes. The second argument would be that variable sum. And so the first argument there represents what you want to be displayed as output. Everything in the double quotes. And up to this point, we were able to display text. But that %d symbol and that \n, we know the \n is an escape sequence. So if we try to print that out, that's just going to print out a line feed. But what does the %d do? Well, the %d is basically saying, when you see the % symbol, don't actually print out %. Print out what's the next argument. So %d is going to actually be interpolated or mapped to the variable sum. Okay? So along with the display of the character string, the sum is, right after displaying the sum is, %d is going to be mapped to the variable that you want to display as well. And then \n is going to be interpreted as a line feed. So this is going to display the sum is, the value of sum, and then a line feed. Now the % symbol tells you that it's a format specifier. The d is telling you that it's an integer. And depending on the type of that data, what's after the % symbol is going to change. Okay, so that's what's going on with the printf function. The % character is what's important in terms of the format specifier. It's a special character recognized by the printf function, and what immediately follows that % symbol is going to identify the type of the data that we want to print. The type of the data that we want to print is just going to be a single character, like this is D. The data that we're going to actually print is after the comma. And so you can put many, many different percent symbols in there to print many different types of data. And we'll go through some examples. So here's an example where we're creating some variables of different types. We're creating an integer variable, a float variable, a double variable, and a character variable. And we're assigning all these different data values to them. We then want to display these actual variables values. And so what you should see here in these printf examples are after the percent symbol, there's different letters. We have %i, %f, %e, %g, and %c. Again, those letters identify data types. %i is going to represent an integer. %d also represents an integer. %f represents a float. %e is actually going to represent a double. %g is going to represent a double as well, just a different format. %c is going to represent a character variable. And then Boolean values, remember we mentioned that Boolean values are true or false, 0 or 1, so you could use a %i there as well. So let's go through this example in code blocks. So here's our familiar example, our main function, our main program. And I'm just going to copy and paste in the values that we had for our little program that had different data types. Just give me 1 second. So this is the example from the slide. Again, I have pretty big font here, so hopefully everyone can see it. All we're doing in this example is we're declaring some variables of different data types. So on line 12, we're declaring a variable named of type int named integer var, and we're assigning it 100. So we're initializing and declaring variables. We have an int. On line 13, we have a float. Line 14, we have a double. Line 15, we have a character. We know that it's a character because it's inside a single quote. And then our Boolean, which we can just use underscore bool, again, is what was defined in the C99 standard, but we can just use bool. I think that would be better. And then we can set that to 0. The printf function, remember, that's displaying the output. And the first argument inside the double quotes is going to be what's displayed to the screen. The second argument is going to be mapped to what's the format specifier, %i. And then the \n is just printing new lines because that's an escape sequence. So if I were to run this code, first I need to compile. And let's see, it looks like we have an extra character somewhere. Probably with my cutting and pasting. Whoops. Just want to make sure I don't have anything here. This is basically, this error is saying there's an extra character somewhere I'm trying to figure out. Hidden somewhere. There we go. These spaces are creating problems with my cut and paste. And the way that we know there's no errors is because now we see it's highlighted. When you're in code blocks, one of the ways that you can identify errors is this color coding. It will tell you. So if you see things that aren't highlighted, it's usually a good indication that something weird is going on. So now we save it, we build it. We do have a unnamed type bool. So we're just going to use bool for now. We still have some bad characters here, and we know that because the printf is actually not. Let's see. Again, I should have copied and pasted this. I copied and pasted this from the PowerPoint slides, and it basically added all these weird characters. So now I have to make sure they're not there. And now we have no errors. Not sure why I wasn't able to use bool. This might. Oh, because it's a C++. So bool is actually for C, not defined as an alias, I think, until the C11 standard. So let's just continue. Well, you have to use underscore bool. All right, so let's run this thing. And what we'll notice as output is it's going to be displaying the output. So you'll notice again, try to look at this both for the output, that it's displaying integer value, so it displays whatever in the quotes, right? And then %i gets mapped to whatever the value is of integer var. which is 100. So %f is going to get mapped to floating var and vice versa. So what you see output is integer var equals 100, floating var equals 331.79, so forth, double var and double var. And you'll notice the format's a little different depending on the specifier you provide. You also notice bool var is equal to 0 because bool is an actual integer. And other things that you should notice is in line, the floating var is actually printed out as 331.790009, but we assigned it 331.79. And the reason it's displayed with more precision is because of the specifier f, and depending on what machine you're in, because it's machine independent, it may display differently. And so this is just an example of how you can use format specifiers. And also, if you wanted to print more than one variable on the same line, so we could actually put what else we want in here, anything else inside in here, and then we could do another thing, %d, or let's print out the floating var. We could do %f, and then all we need to do if we want to print out two variables, we add another comma, and we say floating var. So you see what I did here? Is I wanted to print out two variables on one statement, one print statement. So I added another format specifier, and then I just added another comma to specify the variable that I want to print. So you can put as many format specifiers in between the double quotes, and those are going to get mapped to whatever after the commas for each variable. Again, I wanted to talk about format specifiers because we're going to be printing out data for debugging. It's important to know how to print out variables. And there are all sorts of different format specifiers in the C programming language. I want to provide you with a little illustration of some of the ones you're basically going to use depending on the data type. But format specifiers can get even more complicated. You could put a % here and say 2 dot, and this will print it to 2 decimal points. There's all sorts of nice things you can do with format specifiers to format your data. But we're just going to talk about the basics. Basically, how you use the format specifier to specify the type of data that's going to be outputted, and then put the variable after with the commas. Okay, so you can play around with this. Again, we'll have an activity or a little challenge to help understand this. But this program just demonstrated some declaration, initialization of variables, and then using format specifiers to display them. So let's go back to the slides and summarize some of these different format specifiers that are available in C. So in this summary slide, it actually tells you the format specifiers that you would use for printf in the third column here, printf chars. So if you want to print out a character, use %c. If you want to print out a bool, use %i or %u. And that will print out 0 or 1. In the there's also examples of what represents these data types. Short int would be %hi, %hx, and so forth. The ones that you're probably going to use a lot, int for %i or %d. %d works with int and is usually used depending on the standard. %f, you get associated with that for floats. Doubles, %f, %e, %g. Each one is going to determine the precision. Long double, %lf. Another real popular one is %s for strings, but we haven't talked about strings yet, which are just a sequence of characters. But again, all these different format specifiers can be included to convert data as well as displaying data as output. And we'll be doing a lot of this in many examples. Thank you.